Hello everyone, welcome back to another video. In this video we are going to solve a problem on shear force and bending moment for a cantilever beam with UDL as well as combination of point load or concentrated load. So without any further delay, let's see the problem. Problem number 5. Draw the shear force diagram and bending moment diagram for a cantilever beam. So here is a question. So here is a question. A cantilever beam of length 2 meters. So length is given, that is 2 meters, carrying a uniformly distributed load of 2 kilonewton per meter. That means the uniformly distributed load is 2 kilonewton per meter, that means per unit length over whole length, and a point load of 3 kilonewton at the free end. So we know that for cantilever beam, one end is fixed, let's say A, and another end is free, we call it as B. So here there is a point load as well, that is 3 kilonewton. So the total length is given 2 meters. We need to find shear force and bending moment and draw shear force and bending moment. So first step is to calculate support reaction. So calculate support reaction. So that is summation of vertical force is equals to 0. We know that from equilibrium equation, or you can write f of y equals to 0, summation of f of y equals to 0. So I am writing all the vertical forces because we have a vertical force here and here and uniformly distributed load as well. So I will write here RA. So here is my RA minus I will take this point load, that is 3 minus 2 into 2 meters, that is 2 is a uniformly distributed load acting downwards, making it opposite direction to this RA, that's a minus into whole length, that is 2 meters, equals to 0. From here RA equals to 3 plus 2 into 2, right? So RA equals to 3 plus 4. So that gives RA equals to 7 kilonewton. Clear? So this is how we can find support reaction. So we will know RA, right? So now we'll find out shear force bending moment, because here RA is unknown, we already got it. So no other load to be identified or to find out. So directly we'll jump into shear force, right? So second step is to calculate shear force. Shear force. So we'll calculate shear force at A. So here is our shear force. We know that FA, here we are taking all the left hand reactions or supports, so all the forces on our left hand. That means here at this point there is no left hand forces, so FA will directly equals to RA, that is 7 kilonewton, right? Now we'll find out shear force at B. But before that, let me tell you, we need to find out shear force at B, that is your left and your right, because here is a UDL. So shear force, so I will divide this B into two parts, that is B1 and B2. So first we'll find out shear force at B1. So that is the left. I will write here left side. So in case of cantilever, if you want to find out shear force at B, you need to divide into two parts, that is B1 and B2, that is your left and your right. So that will be my FB1, that is shear force at B1 equals to RA. So here at my left, so RA minus, so what is there? Uniformly distributed load, that is acting upon 2 meters. So this is my shear force at B1. So we know that RA is 7 minus 4, that will become 3 kilonewton. So B1 we know 3 kilonewton. Fine. So now we'll find out shear force at B2, that is the right for B2. So shear force, I will write shear force at B2. So that is the right side. So I will write right side. So here, so is there anything here? There is nothing. So that means whatever the reaction is acting here will be your shear force. That means F B2 equals to 3 minus 3, because here is 3 and there is no other support. That means 3 minus 3, we will get FB3 B2 equals to 0, right? FB2 equals to 0. So now we will find out bending moment. We'll find out bending moment. Step number 3 is to find out bending moment. So I will write bending moment, that is denoted by M. So I will find out bending moment, I will write in short form bending moment at A. So that will be MA equals to, so here, so you need to, for bending moment, in case of bending moment, you need to calculate load into perpendicular distance coming from the right to left. So if it is sagging, if it is making the beam upward direction, that means a smile symbol or a sagging moment, we take positive. If it is making this beam as a hogging moment, we take negative. So for RMA, I will write minus 3 into 2 meters, right? Again minus, because it is creating hogging moment. It is creating hogging moment. So I will take negative. And this uniformly distributed load will also create a hogging moment, which is a sad smile symbol. So we can take negative, that is minus 2 into, so because it is uniformly distributed load, so 2 into 2, and the maximum bending moment for UDL will be in the middle. So we will multiply with the half of this length, that is 2 meters, we divide into 2. Clear? So we got 6 here, we got 4 here. So at A we got minus 10 kilo Newton meter. So don't forget the units for bending moment, that is kilonewton meter. So put a neat box here. Next we'll find out shear force at B, but no need to find out shear force at B, bending moment at B. So bending moment at B will be 0. Will be 0 because it's a free end, right? So that is a property of a cantilever beam. It is fixed. That means the total moment will create here and total loads will take here and creating the moment at A, that is the fixed support. So here at B, so MB equals to 0. So we got MA, we got MB. Okay. So in order to draw shear force and bending moment, in order to draw shear force and bending moment diagram, we need to draw a free body diagram of the beam, that is our cantilever beam. We need to draw a free body diagram. So I will just draw the beam first. Okay. And on this beam there is a uniformly distributed load. So I can represent in this way, and I can also represent like this. So there is no change in this. Don't get confused in the exam. It will ask, it will represent in this way or in this way. The both are same. Okay. So many people get confused here. So bending moment, we need to draw shear force and bending moment for UDL acting on cantilever beam, and there is another load, that is point load, is acting exactly at the end of the beam, that is 3 kilonewton. And what is the load? Uniformly distributed load, that is 2 kilonewton upon meter. That means each and every unit will have this load. What is the length of the beam? S, that is 2 meters. Clear? So now to draw, we need to extend this reference line, isn't it? Just extend this reference line. So for exam point of view, better to draw in a fresh page so that it will be clear to the evaluator. Okay. So draw the baseline, which is A and B. So give the names A and B. Right. We got the shear force value at A, that is 7 kilonewton. So this is 7 kilonewton, which is positive. That's why we are drawing above the baseline, right? So now from here, because of this uniformly distributed load, there is a slight change, and we got shear force at B1 and B2 is 0, and B1 it is 3 kilonewton. So I just stop here at 3 kilonewton and it is 7 kilonewton. I will join this line. Yeah. So if this point load is not there, it is, if for suppose imagine that this point load is not existing on this beam, so it will be a perfect rectangle. So because of this load there is some shear, so that's why we take shear force at B1 and shear force at B2. Is it clear? So now, so this is positive, right? Shade this part. So depending upon the shear force and bending moment diagram, as a civil engineer we need to provide the required reinforcement or required design to be stable, to make this particular beam to be stable. That means we need to ensure that the safety of this beam. Okay, so now let's say this is shear force diagram, and for bending moment diagram draw the reference line. So this will be your baseline, which is 0 0, which is 0 0. Let's draw little up here. So it will be 0 0. So we got bending moment, that is MA, that is 10 kilonewton. So that is minus 10 kilonewton, minus 10 kilonewton. So bring this down through the baseline. Then we got shear force, that is bending moment at B will be always 0. So just join that with free hand like this. Okay, so it will be 0. So make sure that it should touch the baseline. Okay, so this is your bending moment, which is negative. So you can see for the case of cantilever beam, the maximum bending moment is at A, okay, and the maximum shear force is at A and also at B, right? So this is how you can find out shear force and bending moment. So if you are new to my channel, please check the playlist of strength of materials. We are going to cover the syllabus of JNTU H for R18, and it is same for R16 and R15. So please check it out, and in the next video we'll see some more problems on cantilever beam carrying uniformly distributed load, but we have a point load in between or on the uniformly distributed load. We also see some gap in between, that means there is no load here for suppose, and the uniformly distributed load started at point X and it will end at point Y, and also having point load or concentrated load on it. Okay, till then take care, bye bye. It's Mirza Naeem signing off.